using the one-to-one property of logarithms to solve logarithmic equations. Number 1, express the equation in the form of log base b m equals to log base b n. This form involves a single logarithm whose coefficient is 1 on each side of the equation. Notice that they are understood ones in front of the word log. So this is the form we want to get an equation into, is 1 log on the left equal to 1 log on the right with coefficients of 1. When we do get it in that form, let's look at number 2. Use the one-to-one property to rewrite the equation without logarithms. So in other words, if we have this, if we have log base bm equals to log base bn, then we can let the logarithms go and write it without the logarithms and just bring down the m and bring down the n and set those equal to one another. Then step number 3 says, and solve for the variable. Step number 4, check proposed solution in the original equation. Include in the solution set only values for which m is greater than 0 and n is greater than 0. Remember, you cannot take the logarithm of if m is negative or if n is negative. Therefore, that's the reason why it states that m has to be greater than 0 and n has to be greater than 0. So let's use this one-to-one property to solve this next example involving logarithms. So when I look at this problem here, this is a logarithmic equation. So let's begin solving it. I see that I have 1 log on the left equal to 2 logs on the right. To use the one-to-one property, I want to get 1 log on the left equal to 1 log on the right. And I can do that with this equation by condensing these two. So if I was to go ahead and condense, on the right-hand side I have on the left log x plus 7 equals to log. Now let's condense. The plus sign comes from the product rule. So let's multiply x times 7. I'm going to go ahead and just write that 7x. Okay? So now, the next statement here says rewrite the given equation without logarithms. In your online homework, it's going to ask you to fill in the blank for this step here. Rewrite the given equation without logarithms. So my answer for this answer, or the answer for the online homework, if you rewrite this without logarithms, it would be x plus 7 equals to 7x. So that would be what would go on your box on the online homework. So we went from log x plus 7 equals to log 7x. And by the one-to-one rule, we can let the logs go and bring down just your x plus 7 equals to 7x. Now let's solve this equation. Next, we could subtract x from both sides. You would end up with 7 equals to 6x. Divide both sides by 6. So x equals to 7/6. That would be your answer to this problem. Okay? All right, let's look at another one. Final answer there is 7/6. I'll make sure you see that answer. Okay, let's look at another example. Looking at this problem. This one, instead of logs, has the ln. The same rule applies. Let's get ln on one side equal to ln on the other side with coefficients of 1. We want 1 ln on the left, 1 ln on the right, and then we can let the ln's go and solve for the variable. So looking at this problem, I see that I have the 2 ln's here. Let's condense. So I have ln. Now I see that I have a minus sign, so this is coming from a quotient. So I'll put x plus 2 divided by 4x plus 3 equals to ln of 1 divided by x. Okay, so I use the one-to-one property. Or I'm going to use the one-to-one property. Now, being that I have the ln equal to the ln, let the lines go, and I end up with x plus 2 over 4x plus 3 equals to 1 over x. So that would be the answer that you would put in the box on the online homework that says rewrite it without the logarithms. That would be your answer. Now let's continue solving this. You can solve this a couple of different ways. You could cross multiply. This is a proportion. You're welcome to do that. But I'm going to show you to get rid of all of these fractions in the denominator. We're going to multiply each term through by a common denominator. Your common denominator would be x and 4x plus 3. That would be your common denominator, those two together. X and 4x plus 3. Okay? So I'm going to multiply this fraction by x, 4x plus 3. And I'm going to multiply this fraction times x times 4x plus 3. To get a common denominator between these two denominators, I just put them together, multiply them together. So think of this over 1 times this fraction. Well, the 4x plus 3's would cancel, leaving me x times x plus 2 equals 2. 1 over x times the common denominator here. The x's would cancel if you cross reduced. And 1 times 4x plus 3 is 4x plus 3. Now let's continue solving. I have x times x is x squared. X times 2 would give me 2x equals 2, 4x plus 3. Now this is a quadratic equation because I see that I have an x squared. I want to get everything on one side set equal to 0 so I can solve this quadratic equation. Okay? So to do that, let's subtract 4x from both sides. And let's subtract 3 from both sides. Therefore, I would only have 0 on the right-hand side. So here I have x squared. Now 2x minus 4x gives me negative 2x. And then I have my minus 3. So that's my quadratic equation right there. I'm going to rewrite that. I have x squared minus 2x minus 3 equals to 0. That is my quadratic equation. Now let's factor this. Factoring x squared into x and x. The back sign's negative. My signs are going to be different. Factors of 3, 1 and 3. These pair of numbers will subtract to give me 2. So I'm going to use the negative sign with the 3, the positive 1. Now if you were to FOIL these two binomials, you would go back and get what you started with. Okay? Now setting each one of these equal to 0. Let's add 3 to both sides. I get x equals to 3. Subtract 1 from both sides, x equals to negative 1. Now, we want to check these. The main thing is that you check to make sure that you're not being asked to take the log or ln of a negative number. Because if you are, you have to cross out that number. So if I go back to the original problem, and let's plug in 3. Let's talk about it. Plug in 3 right here. What's 3 plus 2? That's positive 5. That's a positive number. If I plug in positive 3 here, 4 times 3 is 12. What's 12 plus 3? 15. That's a positive number. If I plug in 3 here, 1 divided by 3, that's 1/3. That's a positive number. So 3 is good. 3 would only require me to take the ln of a positive number. And if we were to actually work the problem out with 3, the left side would equal to the right side. So 3 is a good solution. I'm going to circle it. But let's check negative 1. If we plug in negative 1 back into the original problem, negative 1 plus 2 is positive 1. I can take the ln of positive 1. Plugging in negative 1 here, 4 times negative 1 is negative 4. Negative 4 plus 3 would be negative 1. We cannot take the ln of a negative number. If you tried to do that on your calculator, you could see that it does not work. Okay? So since negative 1 requires me to take the ln of a negative, and I cannot do that, then therefore negative 1 cannot be an answer. So I will cross out negative 1. Therefore the only problem, or the only answer to this problem would be positive 3.